Hi, everyone. Based on the videos that I did for Jason and Alan Kay and Ben regarding DB Cooper, and then some discussions I had with other people who are fans of the channel, I decided to come out with this video because I want to show you some interesting parallels. I want to just tell you again up front that I'm not researching DB Cooper. Personally, I don't believe that Forrest Fenn was DB Cooper, but he could have been. And actually, this video might give you yet another reason to think perhaps he was. But I was basically focused only on the landing location of DB Cooper. Alan Kay and Ben are the two primary people that were working on this DB Cooper thing. And they had asked Jason for some information. And then Jason contacted me because Jason wanted me to come up with an ending to the flight. And he came up with an ending to the flight without us looking at each other's work. And then we wanted to compare the results so that we can help Ben and Alan better determine where they were going to go. Because like I said, they believe that he jumped off the plane close to Reno, and I agree with them. So while I was doing that work, another fan, and a lot of you guys probably know him, he's been around for a long time. His name is Rick Nowak. Probably been in this, he was one of the first 20 searchers. So he's got more time in the chase than probably anyone. And he's a really nice guy. I talked to him a few times on YouTube. And then yesterday, I was on the phone with him for a couple of hours. And he's seen my video about DB Cooper. And he thought that maybe I'd be interested in doing some research on Amelia Earhart. A friend of Forrest Fenn, I forget his name, but he basically is the one who funded a lot of the research that they did on trying to locate Amelia Earhart's aircraft. Okay, this guy's like a multi-millionaire, $700 million, whatever. He passed away, but anyway, he was good friends with Forrest. Forrest did a couple scrapbooks about him, and unfortunately, his name escapes me. You know, the Amelia Earhart one is a lot more difficult than DB Cooper because DB Cooper was more recent. We had better technology, and we have air traffic control documentation, so I know the plane's heading. I know where the plane was at certain fixes as they reported back. Well, with Amelia Earhart, it's a lot harder because there were no two-way radio communications at all. They were all one-way, and they were messed up because Amelia Earhart actually didn't really understand how to use the radios all that well. There was a lot of confusion. They had mess-ups between the various time zones. And some of the weather reports they were getting back were conflicting. Nothing was taken directly from the area. They don't really have any, except for maybe one or two precise fixes of where she was, because they didn't use radar and they never really got accurate fixes of where she was, unlike DB Cooper. So it's not a matter of just tracking her flight. There are, of course, many theories of where Amelia Earhart plane crashed. Most of them have all been proven wrong at this point, but there's a lot of information out there and a lot of different thoughts, but nobody's actually pinned down where the plane was. One of the thoughts I'm going to share with you today has already been mentioned by the group that's been tracking and coordinating the Amelia Earhart effort. But I don't believe they did with, I'm going to suggest that they do, but they did mention this as a possible confusing thing. And it's very interesting, but there are parallels between Amelia Earhart and DB Cooper. And on top of that, this is the other interesting part that comes in. Our solve, of course, is based around the medicine wheel, the try the wheel stuff. And for those of you who don't know, I just want to make this clear again. Sam Smith, his original partner and him back in 2012 and early 2013 are the ones that figured out try the wheel. So anywhere you hear anybody repeating anything about taking the word treasures and bringing it down that column has been derived from Sam's work. Sam was the first one to discuss it online. And then I eventually teamed up with Sam. And back in 2016, I discussed it on Dow's website. And Dow's website was confusing to because there was no threaded discussion. So when Jenny opened her forum in late 2016, I then started posting there as Why Must I Go? And that's where I posted the original grid and showed you which words to choose and how you spell out treasures and the fact that it reveals the double cross along with try to wheel. So that originated by me, and it was based on the work of Sam Smith and I. So if you want to find anything out about how that works, this is the source right here. Any other information that you're going to get from any other channels is either going to be incorrect or is just plagiarized from our information to begin with. So you might as well get it straight from the source. And I do want to say thanks to those people that based their solve on Sam and I's work, but at least they gave credit to Sam Smith for doing probably 90% of the work on the solution, which is the whole part of figuring out where warm waters halt. So I just wanted to make that clear up front. That's who Sam Smith is. That's where I came in. We are the ones who originally published and copyrighted the stuff related to how to locate the hidden phrase, which words to move, and all of that stuff. We made it public for anybody to use because we had hopes of building a team. Obviously, that didn't work out. Somebody took it and then they used it and they solved the ending before we did, and they beat us to it. That's perfectly fine, perfectly legal, because the information was made public for them to use. However, when somebody posts something on the internet like that and they copyright it, they still own the rights to that work. And although people can use that work to solve the poem, they can't create other revisions of that without permission from the initial author. That would be plagiarism. So now that that's out of the way, I want to mention that both D.B. Cooper and Amelia Earhart are tied to the Bighorn medicine wheel, and specifically Dr. John A. Eddy, who was a solar physicist, astronomer, and he was also involved in celestial navigation. He determined that the wheel is for solstice sun monitoring and other astronomical uses. The cairns labeled A, B, C, D, E refer to the following. A is Aldebaran, the brightest star in the sky for Taurus the bull. The next cairn, B, is Rigel, which is the foot of Orion the hunter, which is the brightest star in the Orion constellation. Next to the sea cairn, but not the sea cairn itself, is Sirius, one of the hunting dogs. That's also the brightest star in its constellation. And then D is Fomalhaut, which is the brightest star in the southern fish, or Pisces Astronus, which sits directly below the water bearer, Aquarius. Now, the E cairn is where you would stand to observe the sun on solstice sunrise. So those are the stars, including the sun, that are represented by the cairns around the wheel. And that was all determined by Dr. John A. Eddy, and he published his work in the 1970s. But I want to mention that in probably the late 60s, the 70s, John Eddy was in Texas, and he took a lot of celestial navigation courses. So he kind of was following along the same trek that Fred Noonan was, who was the navigation for Amelia Earhart. They're the only two people that were on the plane when it went missing. Fred Noonan's fame is from his research in doing celestial navigation techniques while he worked with Pan Am Airlines on their transatlantic and trans-Pacific flights. Because back then, they would have, in the 30s, that you can't, when you're flying at night, you can't use dead reckoning when you're out over the ocean because there's nothing but blackness. So what he worked on was using the techniques that they would use on a ship in order to navigate using celestial objects in the sky to predict where they are as they were going across the dark ocean. Except he used those techniques from in the airplane. But literally, when he would fly, he brought what they call a sextant with him. And he used the sextant in the airplane to basically try to get fixes of where he thought the plane was. And then when the plane would radio back, they could measure the signal strength of the radio and try to calculate the relative distance of where he was, and that would help him confirm it. When he was flying with Amelia Earhart, due to not having the communication set up properly, they were never able to get accurate fixes to confirm anything that he was doing. And remember, he was tracking things in the sky, but he was using techniques that are meant for when you're at sea level, not necessarily when you're up 8,000 feet in the sky. Because as you increase your observer altitude, your eyes in the sky, it changes the time in which celestial objects like the sun or stars are going to appear over the horizon. It changes everything about their altitude, and even depending on if your orientation is wrong, it can change the azimuth, and you would have incorrect results. And if you weren't getting back to a radio as your flight progressed, the errors that you make, even though they may be slight, are compounded by the fact that you repeated those errors over and over. So let me show you a couple things. I'm not going to get into the DB Cooper stuff anymore because you've seen that, but I am going to make references to that near the end of this video. But I'm not going to go over where he landed. You already seen that. But after I made that video, I thought of something, and that's how I found the relationship between DB Cooper and Amelia Earhart and the medicine wheel. So for starters, let's take a look at some of the Amelia Earhart stuff. And I want to show you a few things that I initially found questionable about the flight that they took. And I'm going to tell you approximately where I think they crashed. And like I said, what I'm about to show you, I'm not the first person to take note of this, but let me show it to you anyway. This area down here in New Guinea is where they took off from Lai Airport, which is a historical airport. It's not in use anymore. This red line is their intended flight path, and they were flying to an island called Howland Island, which is right here northwest of Baker Island. Those are uninhabited islands, by the way. And just to get so you know where we are, this is Oahu, Hawaii, over here, up here. Now, I made a lot of marks on here to indicate various things, but the only real reliable fix that we have on the plane is the very first one that we have here that was recorded at 7:18 GMT or 4:18 p.m. local time. The plane was right here based on that fix. So they were on track. Everything looks good at that time. And they took off at 0 GMT. So here they're 7 hours and 18 minutes into the flight. Notice the time. We're getting right near dusk. So the sun is about to go down. So basically, from somewhere around this point, all the way until they got roughly here, they were in complete darkness of the night. Okay? The only thing they could navigate on was on the stars. Now, what we had in place approximately halfway along the trip was the USS Ontario, which was parked here. There was a merchant ship roughly here. And a radio communication came in roughly 10:30. But they really have they were getting radio communications from 3 different sources. And this was really badly planned. They didn't have a single source that was tracking everything. And to make matters worse, some of these places like here and up in Hawaii and from the ship, those are all physically located in different time zones. And not all of them are on the hour. For example, Hawaii is -10 from GMT. But when you're between Hawaii and one of these islands, you're going to be at -10 and a half. So we're going to be dealing with fractional times here. And a lot of them interpreted the radio messages because she wasn't good at operating a radio. The signals were weak. But these signals that I recorded are only the ones that they know were likely to have come from her. There are a lot of radio signals out there that were hoaxes or proved to be hoaxes. They know they weren't real. But this one, and then maybe one more, maybe two more were kind of real, but I'm saying that they were wrong. So the ships are parked here, roughly here. Now, it would have been dark at this point at 10:30 GMT. That would have been about 7:18 p.m. So they'd be in the darkness. But whoever it was, and they don't know whether here, they didn't have an exact fix for it. She could have been here when she seen the ship, or she could have been here and seen the merchant ship, and she would have been off course a little bit farther north. We don't know. And interesting enough, neither one of these two ships seen her. What they did is roughly 1500 GMT, they basically left because the plane had to be past them at that point, and they didn't see her, and they already had a radio contact out here, so they basically left. And it's interesting to note that they weren't commanded to leave. They left because they were running short on food and so on and so forth. They had to get back to land. The merchant ship, of course, continued on its way. Nauru had the radio station there, and they're one of the ones that claim that they picked her up, and they put her roughly 60 miles southwest of where Nauru is. That's why I put the pin here. But it's technically not really accurate. But my main point is from here to here, they were flying in complete darkness. Now, you talk about disorientation. I don't know if you were ever in a plane or on the ocean, in the middle of the ocean, in the middle of the night, but you can't see anything. There are no horizons to see. And you got to remember that Amelia Earhart, when she flew, she stayed between 7,000 and 8,000 feet above sea level. So they weren't really too high from the ground. So their horizon was only off by a few degrees of where they would be if they were at sea level and on the ship. And I'm sure that Noonan was smart enough to consider the fact that he was 8,000 feet above the ground, not on the ground when he was calculating the trajectories for the objects that he was sighting in the sky. I'm going to go ahead and say yes, he was smart. He knew what the heck he was doing. He did this before. However, he was not really, this was all new technology, and using sextants and using celestial objects to navigate airplanes. That had only been he was only trying to use that for like 2 years before this happened with Pan Am. And the very last time he used it, he didn't go south of the equator. He only went from California to Hawaii. And I think he also went to China. So anyway, most of that work was done north of the equator. But you got to take other things into factor. When you're up in the air, you don't really know the plane's orientation to the ground. It may not be perfectly parallel with the sea. So when you're using the instrument to monitor stars in the sky, you're relying on the fact that the pilot is telling you that the plane is at level flight and so on, so forth. So we don't know that that was the case. They never got back. So we don't have any of the records that the navigator Fred used, and we don't have any accurate locations really beyond here. Everything after is all speculation. Down here, there's these islands have natives in there. They don't speak English. They have missionaries with them, and the missionaries communicate with them, and they ask them things like they never seen airplanes and stuff like that. And from their level on the ground, they wouldn't have seen Amelia's plane anyway up at 8,000 feet. They would have heard it. It's going to be completely silent. You're on an island in the middle of nowhere. There's no buildings and cars and stuff like that. So anyway, the natives made indications that they seen it. But the problem is we really don't have any accurate time that occurred. So everybody that was on the radio and stuff are trying to estimate where she was. She never, ever got a reliable fix, ever, except for over here. Never. So you can't really even go by what she was saying, because technically she didn't know where she was once they got beyond, I'd say, where she said she's seen the ship, if that is true. And remember, it's completely dark. you're not going to see any of these islands. Even from 8,000 feet, if you're back here, let's say, you're not going to see land. There's no lights. You're not going to see it until you're, well, even when you're on top of it, you're not going to see it, especially considering there was storms, there's clouds. She's flying in the clouds, not going to see it. So they were kind of relying on the navigator, all right? And over here, when they were roughly 200 miles out, this again was an estimate. And they turned out the time was wrong because the guy who reported the estimate from Allen got it wrong. And he was estimating the 200 miles, or she was estimating 200 miles. Again, she never got a real fix, but they thought they were 200 miles. Another one came in where she thought she was 100 miles out. But the 100 miles wasn't mentioned by her. That was mentioned by the radio operator who had no experience on using the signal strength to calculate distance. So a lot of things went wrong during this flight, especially around this area. So, I mean, there are various people that think the plane crashed over on one of these islands. But over here, there's not really that much. These aren't islands. You could look at the elevation, and the sea is down 17, 18,000 feet to the base of the seafloor. These are all caverns. They're like inverted mountains in the ground, or spikes coming up out of the ground. Okay? These are islands. This is an island. So from here until she got over to this, I guess, nope, that's not even an island. No, there's no islands till you get to Baker Island over there. So there are some down here. There's two of them over there. But all over here, there's nothing. This is just nothing but blackness, water, and so on. Now, you got to remember some politics here. And, this might offend some people that are researching, but I'm trying to be honest. I'm not trying to be politically correct, but you got to remember that Pan Am, of course, is in the airline industry, and Pan Am is trying to make it clear that the transatlantic and transpacific flights are becoming more and more safe due to things like the work of the navigator that is on the airplane with Amelia. In fact, when they finished this run, Fred, the navigator, was going to start a school to teach people how to use celestial objects to navigate from an airplane. That's how big this was. So it was a big thing, right? But Fred was only an amateur pilot, and he didn't know how to use the radios at all. Amelia was not that experienced with the radios either. That's why they were never able to get a two-way conversation, and she never stayed on the frequency long enough, or they never issued on the frequency long enough to give the signals that she would need to get it fixed. Furthermore, they messed up in some cases, not the Ontario, but the Itasca. They messed up some of the times, the GMT. It looked like they forgot that they were a half-hour difference. That's a major, major problem, okay? When you're using celestial objects to navigate, you have to locate the azimuth of the object that you're locating and the altitude, right? And then after you do that, you got to immediately look at your clock, at your time. And you need to be extremely precise, all right? Because if you're at sea level, and remember, he also had to account for being not at sea level, but 8,000 feet in the sky. If you're 1 second off on your watch, just 1 second, okay, that means your calculations are going to be off roughly 1/4 of a nautical mile. And a nautical mile is 1.151 times a statute mile on land. So a nautical mile is 6,076 feet. So 1/4 of that, 1/4 of a mile off for each second. So if he was 2 seconds off, or in any of his calculations, times, GMT, or if their clock was wrong and they, anything like that, he could easily be miles off, of course. And I agree with the people that think that they ended up, they never ever went north of the equator. They're somewhere south. They got lost. And then they started flying north and south to find out where they are. Some people report they ran out of gas, but that's not true because she had enough fuel in there that if she used conservative flight and flew at the 8,000 feet she was told to fly at, she would be able to go 4,025 miles. Okay. 4,000 nautical miles. And the distance from here to Howland is only 2,228 nautical miles. So she had less than she had less than a half a tank left when she was around here. So I don't know how long that they were flying around and what happened with the communications or how they got lost, but they could have either crashed or landed on the wrong island. And of course, nobody knew where they were because nobody lives on any of these islands. So that could have happened. All right. But I believe it happened somewhere down here. And I'm going to show you why. This is the first thing I noticed, and I thought that this is interesting. If we go in here and we turn on the grid, you'll see the longitude and latitude lines. And I want you to take notice of something very important here. Look where they gave their last fix of being 200 miles out, okay? That was approximately at the equator meets the anti-meridian. Like we have in England, we have the prime meridian. This is the anti-meridian. We are exactly 180 degrees away from London, England, or from Greenwich, okay? And here, of course, the equator, we're halfway around the world. So this is where you switch from south of the equator to north of the equator, and this is where you would switch when you're on this side of the line. You're west of Greenwich. When you're here, you're east of Greenwich. Note that. I mean, when you're at Greenwich, it starts at 0, and then it comes around the world, and we got 176, 177, 78, 79. This is where 180 would be, but you'll notice now it starts counting down because we're east, all right? So if he made any of his calculations wrong, the problem comes when he tries to take his bearings and plot them on his chart, because that's when he has to factor in the fact that you would have, negative longitude here and a positive longitude here. Because remember, he's doing addition, subtraction, and a lot of spherical trigonometry, all right? But if he doesn't take that into account, he's going to get all screwed up over here right at this point. And I'm not the only one that's seen that. So don't you find it kind of odd that in the middle of the night when they were here, that's where she reports the first incorrect location, and that's pretty much where radio silence comes in. The sunrise would have been when they were right around here. All right. So he would have been taking readings around here to try to catch the sunrise. The sun was rising at 67 degrees that day based on the almanac charts. So he would have been looking with a sextant up around 67 degrees to spot that. When he plots that down on his chart, he's got to correct for the fact that he's switching from west to east here at this international date line. Of course, he crossed over the international date line. That's where everything happened. So what, in my opinion, what's likely is that Amelia Earhart died and Fred died due to a result of his navigation error. Not her piloting, but it was his navigational error that threw them off track. And then they got lost, and then they couldn't find the island. They were off. It was too late to recover, because the only way for him to recover is to have a good fix. Because you can't calculate any of the angles of your sextant unless you know where you are. And so, like, in other words, he would have to calculate like here, and he knows where you are based on her compass setting on the plane and how fast they're flying and how far they went. And he can estimate where they are. And then he does it again using celestial objects. And then he has to keep doing it and doing it and doing it and doing it. He's waiting for the sun to come up now, because that's going to be his next celestial object. But when he plots that on a course, he was right around here. he's going to end up plotting it incorrectly. Also, you have to remember the fact that the weather reports that came in were not accurate. They were not from on site. So depending on how many knots the wind was blowing, or whether they had headwinds or tailwinds, not only could it slow the plane down or speed it up, but it can push the plane off its course. So they could have been flying down here, instead of like right around here, they could have went like this and slowly off track. And they never got any fixes on their position. So that's my thing with that. I believe that he's the cause. Fred is the reason why she went down. The way to find out where she is what you have to do is try to put yourself in Fred's shoes. And you'd have to go back, and then you would have to plot a course yourself and under the same weather conditions, and see where he may have made a mistake, and then try to figure it out. I mean, it's a lot of work and a lot of math. And I don't believe they landed on an island, so it's going to be impossible. I mean, the plane is 18,000 feet below the surface of the water. It's going to be really difficult. So let me show you a couple tools while I'm at that. The first tool I want to show you is a nautical almanac. You could come here and you could locate charts that'll tell you where the stars are going to be, where the solstice sunrise, solstice sunset through history. And it's a really good place to get that information. You kind of have to know what you're doing to use the charts, and I'm not going to explain it. If you want to learn how celestial navigation works, there's a lot of ways that you can learn that, but it's pretty cool stuff. And I mean, it's old technology, but if you didn't have a cell phone and you were out in a raft in the middle of the ocean in the middle of the night, if you don't have any idea what you're doing, how to navigate anything, you're never going to be able to try to figure out where you are. I mean, you could use mountain man wisdom and say the sun rises in the east, but that doesn't really work because depending on the time of the year, the sun might rise in the northeast. Okay, 67 degrees is not 90 degrees. And that's where it was rising in July when they were lost at this flight. So 67, 70 degrees, that's not directly east. So you kind of got to know what you're doing. You got to know how to locate the North Star, the South Star, and that gets to what I want to discuss next. But one other site I want to show you first is Stellarium. And I use this a lot at the wheel, and I think I might have showed you this before. Here's two of the wheel stars. Here's Rigel and Sirius. But this shows you everything. Right now, I have this programmed as if we are at the place where that strip of islands is. That's about halfway between Amelia Earhart's destination and where she took off from. So we're about halfway there, and we're looking east. And I have the time frozen on July 2nd, 1937 at 14:18, okay, which is when she reported she was 200 miles west of the island. This is, and of course, I don't have the ground on because we're in the water. You can keep it on, but, imagine that the screen is all water. This is what your horizon would look like. I just don't have it on. And here's your celestial objects. But here's the sun coming up. Like I said, the sun will be coming up just as she said she was 200 miles. But remember, we're standing on the Earth's surface here. We're not 8,000 feet in the sky. If we were 8,000 feet in the sky, the sun would have looked like it was coming up when it was down here. Because we're higher in the sky, our angle of observation changed. Right? So here's the sun going up during the day. That's how it would have looked that day in 1937. So for those of you that want to experiment and look at the stars that he was using in order to navigate, you could do it in here. It's pretty cool. And by the way, you could see, this would be the observer looking north during the day, right? And you can see Polaris there. If you look at that little white dot, that's Polaris spinning around in the north. That's the North Star. And in the almanacs, what they do is they take like one planet and they give you the angle in the celestial sphere from that planet to the star. And then they track every 10 minutes that planet, or not that planet, that main star. And then your other star would be referenced from that. So now, obviously, if you're in the northern hemisphere, you would use Polaris. If you're in the southern hemisphere, they use completely different stars in order to navigate. Sirius and Orion or Rigel are used to determine your heading to the east. And then, like I said, the North Star would determine how far you are from the north. In the west, they also have similar stars. And Fomalhaut is one of the ones that they use in the southern hemisphere because Fomalhaut sits on its own. And it's very easy to identify in the sky. It's going to be the brightest thing sitting on its own. Let's see if we could see it. Here it is right here. That's Fomalhaut. This is the D cairn. With the D cairn, if I was standing at the wheel right now and I was looking, Fomalhaut would actually be, if the horizon was here, at the wheel, Fomalhaut would be right over the D cairn. 30 days, I think it is, after the solstice. I don't remember. I talked about it in my other video. But that's the D cairn, like I said. So all the stars are named. This is called the Southern Fish, Pisces Australis. And then, as I said, there's Aquarius. And Aquarius is dumping his jug of water into the fish's mouth, which is the D cairn, where warm water salt. That's what's pointing at Five Springs Basin. Five Springs Basin is right below that. But anyway, that's also called the loneliest star, like I said, because it's on its own. It's the brightest star, and it's in an isolated location. It's easy to find. So they use that for navigation in the southern hemisphere. And Fred would have known that because Fred was, he knew how to sail ships. So he knew how to navigate in the north and the south. He knew about these stars. In fact, if you go out there and search for Amelia Earhart and Fred, you could find a PDF where he discusses these same stars. And that's what gets into my very final part here. How does all this reflect back to the wheel? Well, I already told you it reflects back to the wheel because the wheel is there to look at these same stars that the navigator was using on Amelia Earhart's plane. And also John Eddy, who is the guy who discovered stars and what they represent at the wheel, was an astronomer and also a celestial navigator who was the same age as Forrest Fenn, and he studied the wheel and then did his report on it in 1972. So where does D.B. Cooper come in? Well, I just want to leave you with this. I believe that he was talking about Amelia Earhart because of these references that I pointed out. I believe he was talking about Lovell, the astronaut, because Lovell is the one who put his thumb over the Earth and said he covered up billions of people. And you already know how Tom Hanks and all that stuff relates to Philadelphia. So that's where that reference come in. But that's Apollo 13. Lovell they were supposed to land on the moon. Lovell, who was the commander of Apollo 13. They didn't land on the moon because of failure of their oxygen system. The light was blinking. So they had to turn and come back to Earth. They aborted the landing. So he was the first man behind the moon, but they couldn't land. They didn't land on the moon. All right. So he was the first man to see the dark side of the moon and look back at the Earth. Okay, that's number one. Number two, so all of that stuff was to get you to Lovell, which gets you near the wheel, in my opinion. All right. So with D.B. Cooper, here's the interesting thing I want to throw back to Ben and Jason and Alan Kay. And again, I'm not trying to solve it, and I really don't believe Forrest Fenn was D.B. Cooper. But how do you know that D.B. Cooper did not use a sextant in the back of the plane to navigate using the stars at night so that he knew when to jump out of the plane? Think about it. He doesn't need anything in there except maybe an altimeter. I don't, but he can estimate that. And you got to remember that he told them to fly at 10,000 feet. So he was assuming he was at 10,000 feet the whole flight. That's what he told them to do. So we have the altitude is known. The only thing that's not known is his longitude and latitude. But he could have been calculated that in the back of the plane with a simple calculator using a sextant that would fit easily in his pocket. So if Forrest Fenn was D.B. Cooper, keep in mind that he is also the same age as Eddy, who incidentally died in 2009. And he knew that he did all the research at the medicine wheel with stars. So essentially, Forrest Fenn used celestial navigation to get me and Sam to the treasure chest because we followed the sun away from the wheel and we used Fomalhaut to navigate to where warm waters halt. That is one of the key reasons why the poem works. Everything that I'm telling you about Fomalhaut and these stars is all described at the wheel. He didn't have to teach you anything about celestial navigation. But if you wanted to pick up on the hints in the Thrill of the Chase and the scrapbooks, whatever, of Amelia Earhart and the Town of Lovell and Dr. Eddy and celestial navigation and Fred, the navigator of Amelia Earhart's plane, this might be why. And who knows? Maybe Forrest Fenn was one of the first people to think that Amelia Earhart's navigator screwed up when he crossed the international date line. Think about that. That's really all I have to say. I hope you guys have a good day. I hope you enjoy this. Please click like. Please subscribe. Peace.